probability, a lot of times we need to know how many possible outcomes there are. And we can do that, as you can kind of see in the example here. If I wanted to toss a coin and roll a die, how many different outcomes I could have. And you get heads or tails, and if you get heads, then you could have the 6 different numbers on a die, and if you get tails, then you'd have 6 different numbers. But instead of making this tree chart every single time, we want a quicker and easier way. Well, there's actually 3 different ways. The first one, which we're going to talk about now, is the fundamental counting rule, but then there's also the permutation rule and the combination rule, which we'll get to later. But basically, what the fundamental counting rule says is, well, we'll look at it. In a sequence of events in which the first one has K1 possibilities, and the second event has K2, and the third event has K3, and so on and so forth, you basically can just multiply them together and figure out how many total outcomes there are. So if you go back to this one, we could make this tree diagram, and the cool thing about this is I can see every possible outcome. Heads 4, heads 6, tails 1. I can see all of them. The problem with the fundamental counting rule is you can't see all the outcomes, but if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we know there's 12 outcomes. Well, if you toss a coin, how many outcomes can you get? Well, 2, heads or tails. And if you roll a die, how many outcomes can you get? Well, 1, 2, 3, 4, 5, or 6. If you multiply 2 times 6, you get 12. And that's what our fundamental counting rule is saying. We can just multiply the number of each event to find the total number of possibilities. Let's look at an example. A paint manufacturer wishes to manufacture several different paints. The categories include color, type, texture, and use. And you can see that you have different choices within that. How many different kinds of paint can be made if you select one color, one type, one texture, and one use? Now, we could make a tree diagram, or we could make a list of everything, or we could use the fundamental counting rule. This is our choices. We choose a color, we choose a type, a texture, and a use. So, how many choices do I have for color? 1, 2, 3, 4, 5, 6, 7. How many choices do I have for type? 2. Texture, 1, 2, 3. And use, 1, 2. Fundamental counting rule says you can multiply that together. And when we do that, we get 84. So what does that mean? There are 84 different paint combinations. Great. Now we can use that maybe for some probabilities. The downside, though, is we can't see all the different possible combinations. One more example. The manager of a department store chain wishes to make 4-digit identification cards for her employees. How many different cards can be made if she uses the digits 1, 2, 3, 4, 5, and 6, and repetitions are permitted? And this is going to become important later. Here's what we mean by repetitions. She wants to make 4-digit cards. So I usually start by writing sloppy, apparently, 4 different spots. She's going to use the digits 1, 2, 3, 4, 5, and 6. That means for my first digit of my identification card, I have 6 choices. How many choices do I have for my second digit? Well, repetitions are permitted. That means I could use 1 and then 1 again. I could use 2, 3, and then 2 again. So I actually have 6 choices for the second digit, 6 choices for the third, and 6 choices for the fourth. If repetitions weren't permitted, as we're going to get into later, that's when you're going to get somewhere it's like 6 times 5 times 4. But we'll talk about that later and what that means. Just by multiplying all these together, though, you take 6 times 6 times 6 times 6, and we get 1,296. So it's a 4-digit identification card. I find it helpful to make the 4 like lines here so I know how many I'm dealing with. I had 1, 2, 3, 4, 5, 6 possibilities for each of these digits, and the counting rule says we can multiply them together to know that we have 1,296 different 4-digit identification cards.